the breakdown that you see here looks at those 5 categories of or qualities, if you please, of the code. And the usability is being derived out of direct observation in the code itself. And if you send me a one-liner, I will look up at the definition of what are the rules, what are the various rules that violate usability. Any other question before I move on? Okay, let's talk about technical depth in the context of governance. And Michael Ma, who is sitting here, and Jim Highsmith and myself were actually touching upon various aspects of this governance in recent publications that we did. So I owe many of the ideas here to Michael Ma's work on metrics and productivity and to Jim Highsmith's work on governance. What you see on the left here is the traditional triangle by which corporations look at projects. So you have scope, schedule, and cost. Now, when you look at things this way, it's very, very difficult to relate to the dimension of quality, and it's very, very difficult to relate to the dimension of value. As a matter of fact, they just don't appear in the triangle. The idea that Jim suggested, I think, a year or 2 ago, was to move into the so-called agile triangle. The agile triangle has 3 edges. One is constraint, which pull together the schedule, the scope, and the cost from the one on the left one. So all those are constraints that we need to satisfy. Of course, we can't break the budget. We aspire to deliver on time, and we aspire to deliver the functionality we talked about. So if you please, the triangle on the left edge has been complexed in entirety into one corner. Value is at the top of the triangle. And while various companies use various frameworks for value, I would say measures like net present value of a product are quite characteristically used when you try to look at the value dimension. Quality is a major third dimension, and if you have been here during Mike Kottmeyer's discussion a little earlier, there was actually a dialogue between himself and somebody in the audience about delivery at a certain level of quality and the playoff between delivering more and lowering quality versus improving quality and delivering less. So the quality here is the third element, which assumes that we are gonna deliver high enough quality software, not just software, with the kind of phenomena that Capers-Jones speak about. And the way this is being done is through using the common denominator of the dollar. If you take a look at cost, obviously cost is expressed in dollars. The team spent $500,000 today. The team has a budget of $1 million or whatever the metric is. If you take a look at value expressed as net present value, this is the current value of the revenue stream that the project will generate. And let's say it's $10 million or $20 million or $50 million or such figure. If you go back to the technical depth figure that we talked about before, this is also expressed in dollars. For example, if you take a look at the project portfolio portrayed here, project P1 has a technical depth of $236,000, while project P4 has $3,400. So what we have through technical depth is the ability to express it in dollars and to compare those dollars to the cost dollars and to the value dollars. Let me show you a few typical usages of this usage of the dollar in all three corners of the triangle. Here is the first one. You have a pie chart which describes your technical debt as portrayed here. It's obvious that the $500,000 of debt are primarily due to this red sector of the pie, and this one is test coverage. So you are able to think and plan and execute in terms of strategies like we will not ship the product before 70% of the technical debt on our unit test will be paid back, and then during the first year of the product, we will be paying the rest of it. Again, this can be done between business and technical people. You don't need to know anything about the deep details of software engineering. Here is another example. What do we do when we build software? I build the software, and let's say I have a compile error or a bunch of compilation errors. I, as a developer, do not start bitching that it is my boss who is unreasonable or that this is corporate policy or something like that. I go back to the code, find out all the places marked in pink, and start fixing them until the build goes through. So the dynamic of the build is that programmers do it and are willing to accept it as intrinsic feedback. Namely, if it did not compile, it's obvious to everyone that the onus is on me as a programmer to fix it until it compiles. Now, what we can do is add technical debt criteria to the build and fail the build whenever the technical debt criteria are not satisfied. For example, if you take a look at the first one, which one of my clients is using, what they do is whenever the technical debt goes high, namely the figure is higher than the previous one, they fail the build, and everyone goes back towards fixing things till the technical debt goes to its previous level. Now, you might say that this could be disruptive, and in some ways it's disruptive. However, if you think about the nature of programming, this is actually extremely effective and extremely efficient. If right now, when the build failed, we are looking at why the technical debt went higher and fixing it when everything is fresh on our mind and we know what was checked into the code, etc., the number of people that would be involved and the number of hours that will take them to get the technical debt under control would be fairly minimalistic. While if I come to the code 6 months down the road and I try to push back on the technical debt, oh my gosh, who remembers the code, who remembers what happened, etc., etc., etc. So failing the build, particularly if you build multiple times a day, whenever the technical debt goes high, is really a way of baking quality one build at a time. So instead of looking at $500,000 of technical debt towards the end of the project, you have this ongoing metronome, if you please, which clicks whenever the technical debt goes up, and you can this way push on it in a very effective manner. Another example, you fail the build when the technical debt is more than $2 per line of code. The big advantage of going in this manner is that it gives you a sense of how good or how bad the code is. If I just look at the times that the technical debt goes higher, I get valuable data. At the same time, the technical debt could be, from the beginning, quite significant. And unless I have a ceiling of technical debt not to exceed $2 or whatever amount I decide, then it's very easy to continue to work on code which is of unsatisfactory quality. So this enables you to set up your economic policy in terms of which code is acceptable and which code is not acceptable. Maybe you can get away with a technical debt of $2 per line of code. You certainly cannot get away with technical debt of $5 per line of code. I would actually propose that you had better start afresh. The third algorithm or third policy proposed here is applying technical debt in process control style. You have for any process the mean of the process, the upper control limit, and the lower control limit. And usually, if you remember the charts that Michael has shown earlier, those basically were upper control limit and lower control limit, 1 sigma above the mean and 1 sigma below the mean. And you can set the control limit to any number of sigmas that you desire, 2 sigmas, 3 sigmas, etc. Let's say we built we had 10 builds today, and while the technical debt fluctuated, in the last one, it went above the upper control limit. At this point in time, from statistical process control, you have a major deviation that you would be wise to look into it. So we don't fail the build each and every time the technical debt goes up. However, if it goes up beyond the upper control limit, we fail it at this point in time. One other thing which is very, very useful, instead or in parallel with failing the build on the overall technical debt amount, you may want to look at components of the technical debt, and complexity is usually one of the things that are highly correlated with errors. So you could put in a specific criterion like fail the build whenever the complexity exceeds the level of 5 per method. So between the ability to measure technical debt and the dynamics of the build, you have the ability to really push back on the accrual of technical debt. And I would say which way is best suited is a question of your own environment and your own economic policy, but probably one of those 4 would suit you.
That's true.
Yeah.
You made a analogy earlier in your talk about the banking crisis and how we wound up paying the piper later because of critical mistakes done early on that created this wave that was just building. And one of the things that I'm seeing with statistics from projects offshore, which oftentimes are mandated by CFOs who look at lower labor rates for India programmers, don't realize that when we look at offshore projects, the technical debt is quite high. The difficulties of collaborating across the ocean and time zones and all that are showing from our statistics sometimes, like I said, 3 times the rate or 280% of the defects compared to industry averages. Now, that amount of technical debt in the code, which is increasingly being dictated to occur because of CFOs looking at lower labor rates, like one man's technical debt is another offshore company's future revenue stream. It's the Dilbert cartoon of I'm coding myself a new minivan, right? Because the total cost of ownership isn't just the development cost, but it's paying down the technical debt. So one of the things that's difficult about this from the standpoint of a CFO that's just looking at lower per hour labor rates when they decide to ship work to faraway places to save money is that, would you be able to frame this conversation, frame this argument so that they could understand that they're creating a larger problem downstream, a banking crisis downstream, when they do 3, 4, 5, 6 releases like this with 5 times accumulated technical debt, lots of minivans being coded,